started. Okay, so once again, good evening to everyone. I hope you're all doing well. Welcome to today's session where we'll be looking at Learning Unit 5. And this is a section called Basic Probabilities. So I'm hoping that you have had a chance to read through the content of the learning unit as always, so that you're not entirely lost when it comes to these questions. And then we'll be going through this revision worksheet. So there's quite a few questions on this revision worksheet. It's 10 of them in total, but they are a bit long. So we'll see how it goes in terms of the time and how much we are able to get through. But there's some of them that are quite similar to each other. So I am possibly going to leave out about one or two of the questions, and then you can use that as extra practice for yourselves. So this is a learning unit that really starts to bring in the more statistical part of the module. So we start to look at, instead of, and that's how the module works, the first half of it is very mathematical based. It's most of your calculations are stuff you would have come across previously. It's proper maths involved here. And then the second half of the learning unit, which is learning units 5, 6, 7, 8, and 9, well, actually just more than half the learning unit, is where we look at the more statistical part of the module. So this is the first of those learning units, and it's also included in your assignment 2. It really is one of the more enjoyable sections, but obviously it does have its tougher points where, again, as I said, it's where you start to deal with a lot of statistics in terms of calculations, formulas that are used, methods that we go about, that we use to calculate certain values, and so on. So it really is important, as always, to read through your theory so that you have a basic understanding of what these concepts are, of some of the terms you'll come across, because a lot of the time, naturally, something will be mentioned in a question, and you do need to know what we mean by that. So it is important to please make sure that you go through your slides, because they have everything that's relevant for the learning unit, and then it makes it easier for you to answer your questions and understand what a term means or what this rule is about, and so on. So please make sure that even if you haven't already done that, go back after the session, read through the learning unit, read through the slides. It will be quite straightforward as compared to your textbook. There are examples. Look, it's a long learning unit. So if you look at my slides, it's also quite long. There's no denying that. It's about 86 slides, if I'm not mistaken. However, it is only 86 slides because I have included additional examples for pretty much everything, just so that you are comfortable and you're able to practice and you're able to get as much out of that section or that particular concept or calculation. So it really is only long because of that. I honestly would say about 50% of the slides is just examples. So ultimately, by going through the slides, you're not just learning about the content of the learning unit in terms of theory, you're also getting practice with the examples included there as well. So please make sure to go through that. So the section, as I said, the learning unit is called Basic Probabilities. It is included in your assignment 2. It is a compulsory question in your assignment 2, and it is honestly the basic of the basics. It's where we're introducing the idea of statistics to you, the idea of probabilities, and we are looking at pretty much what sets the foundation for what will come in the next couple of learning units. So there are additional videos or recordings that I will be making available to you for this learning unit. It's quite a few. I think it's about 3 or 4 more videos apart from the session that we're on at the moment that I will be making available to you. It's just additional examples of the same type of thing we'll be going through here, but just reinforcing your understanding of that, of these calculations. So I will let you know when I have uploaded those, but just so you know, there are additional resources that will be available for this learning unit, because again, this is where you really start to get into the more statistical part of things, and you naturally then need a little bit more support as compared to what you previously needed for the first 4 learning units. Okay, so let's get started with these questions. So this is the remember section called basic probabilities. I'm going to just write that at the top as well, so we know that this is the learning unit we're working with. And this revision worksheet, again, you can download it live on the session if you'd like, or you can just wait for me to upload it to VC Learn, whichever you prefer. And then if you're downloading it now, remember it's the top right hand corner that has the download icon that looks like this. So the first question, and this is something that's really, really commonly asked. In fact, I'm pretty sure that your question 1 of Learning Unit 5 section in your assignment 2 also looks something like this. It's something called a two-way contingency table, and it really is so, so commonly asked. You can pretty much guarantee something like this in your exam as well. It's where you can use one table to ask so many different things. Okay, so this is called a two-way contingency table, and it says to you that the following contingency table gives the results of a sample survey of South African male and female respondents with regard to their regular mode of transport. Now, what I'd like to point out here is that firstly, there are 2 variables that you can identify from this table. The first is the gender of a person, so either male or female, and then the second is the mode of transport. So in the table, this is basically saying to you that you are able to read the table in such a way that you can get information for either one of the variables or both of them at the same time. So what do we mean by that? Now, if you look at your column total and your row total. So basically ignore everything else and just looking at the totals. So that's that, and then here as well. Everything in the margin, basically. So everything that is highlighted here in the table, these are called marginal frequencies. And you'll see that in the slides as well when you read through it. So you have a marginal frequency or a marginal probability. It's the same word, so frequency can be used synonymously with probability. So I'm just going to write that here. So marginal frequencies or probabilities, literal to the word marginal, they're found in the margins of the two-way contingency table, and they explain one variable to you at a time. So they explain only one thing to you. So they explain one variable, and what we mean by that, and I'll just give you one or 2 examples, is for instance, if you take the number 175 here, what it's saying to you is that 175 people, and here's your total. This in the corner, the last value in this table on the right-hand corner at the bottom is always your sample size. So it's basically saying to you N, which is denoting your sample size, is 400, meaning that this is the total number of people that had been surveyed. It's the sample size. So basically 175 is telling us that 175 out of 400 people use a bus as a regular mode of transport. Or even if you take the number 210 here on the corner here at the top, it is 210 of the 400 people that are female. So the way in which you read the values in those total rows and those total columns, and I'll even look at the one at the bottom. If you look at the table at the bottom, for example, 250 here is telling you that 250 out of 500 people use Vodacom as their preferred service provider. Or even the number 250 here tells you that 250 out of the 500 people are female. So the values in the columns, in the total column and the total row are referred to as marginal frequencies or marginal probabilities. And then you have the values within the center. So now let's erase this and look at the values only within the table. So basically, let's put a square around it. So basically, all of these values. Ignore the total row and the total column. It's everything within the table. These are referred to as joint frequencies or joint probabilities. So a joint frequency or a joint probability. So it's called joint because here it's explaining two variables to you. So explains two variables at a time. So for instance, if we had to look at the value of 40 in the table, 40 is telling us two things. If you go up to the heading of that column, it's telling you that it's taxis as a regular mode of transport. And if you go across to the row heading, it is telling you that they are male. So basically what we're saying is that 40 out of the 400 people are males who prefer to use a taxi, or males whose regular mode of transport is a taxi. So again, for instance, 60 here is telling you that 60 out of the 400 people are females who use a car as a regular mode of transport. Okay, so that is something that you will also again come across in your slides, also in the other videos that I will upload. Let's look at the questions. So we saw that there are two variables. We also saw that the variables are gender and the mode of transport. And we saw what a marginal frequency is or marginal probability is, as well as a joint probability. So the first question here says to you, what is the probability of randomly selecting a female respondent from the sample? So the moment you saw in this question that they mentioned to you only one variable, they just mentioned the gender of the person. They didn't mention the mode of transport. They were only looking at the gender. Immediately it says to you, if there's only one variable that they're asking you about, your answer will be found in the margins, meaning that it is a marginal probability where they're only referring to one variable, not both. So immediately that says to us that we know we're getting our answers either from here or from this at the bottom, this row at the bottom, or from this at the bottom, this row at the bottom. So all we're going to look for is the one that says female. So I'm just going to take out the highlight here. So you'll go to female and you simply go all the way to the end so you can get to your total, and that's 210. So here your answer would be 210 out of the 400 people. So this is now something that you need to look at in terms of what your question, so whether it's an assignment or whether it is your exam, you have to look at what they asked you to leave your final answer at. So sometimes, very commonly, they'll say to you've use or leave your answer as a percentage to two decimals. Or they'll say to you, leave your answer as a fraction in its simplest form. Or it'll say to you to leave your answer as a whole number. So maybe they'll say round off to the nearest whole number. So you need to then look at specifically what do they say to you in terms of your rounding off and how they want the final answers. So very commonly we work with the first one, also very commonly the second one. In fact, all of them, it really just depends on the question that's being asked. So in this example, we're going to stick to the first one. We're going to leave our answers as percentages to two decimals because it is the most common out of the three that is used. So we're going to leave all of our answers as percentages to two decimal places. So here for this question, we did calculate it to be 210 over 400, but when you convert that to a percentage, that would be 52.5%. Sorry, I'm squashing it up here, so let me leave more space. So it's 210 over 400, and that would be 52.5%. Okay, and that's question one done. Then question two says, what is the probability of randomly selecting a respondent from the sample who travels by bus? So again here, all they're saying is that the person travels by bus. They haven't specified to you what the gender of the person is, so that immediately says we're only looking at one variable, the number of people that travel by bus. So you're again going to work with either value from the total columns or the total rows. And this is then here, there's the bus as your mode of transport. So it will be the answer of 175 out of the 400. So I'm going to, I honestly don't know where to squash this. So I'm going to just write it here as a fraction, 175 out of the 400. And then as a percentage, I'll write it on the side. It would be 43.75%. Okay, so that's question two, and you have now looked at two questions based on marginal frequencies. Then the next one says, what is the probability of selecting a person who is male and uses a taxi? So now you're going to go to the table and you're going to firstly identify from the question that they mentioned two things to you, not one. They said that the person is male and they said that the person travels by taxi. So you're going to highlight taxi at the top and male here and in line with both those values. So in line with taxi and in line with male here, it would be the value of 40. So basically 40 out of 400 people would be, there's a possibility that it would be 40 out of 400 people are males who use a taxi. So that would be 40 over 400, and as a percentage, that is 10%. Okay, so that is C done. Then they say to you, what is the probability of randomly selecting a respondent who is male? And now this is an interesting one. So this is something, again, that you'll need to make sure that you read through in your slides. They say to you, what's the probability of selecting a respondent who is female? But it's given that they travel by bus. Now, what do we mean by that? If you look at the wording of this question, they said to you they want to know what's the probability of it being a female, so probability of it being a female, but they know, so it says given that they travel by bus. So they know in advance then that the person travels by bus. Now, this is something called a conditional probability, or it's also called a dependent probability. So why we call it dependent or conditional is because this event occurring depends on something else already having occurred. Meaning that we already know in advance that the person travels by bus, but now we want to know, given that we know they travel by bus, what is the probability that it will be a female that we're referring to? So basically, in advance, you already know that the person's mode of transport is a bus. All you're trying to determine is the gender of the person, whether it is a female or what the chances of it being a female. So here to calculate this, instead of the total sample size, instead of 400 being the denominator, what happens is we're able to narrow it down. So normally for the first two calculations that we saw, we used 400 as a denominator because it was looking at the possibility of females from all 400, and then we looked at the possibility of the person traveling by bus from all 400 people, and so on. Now, what we're doing is, because they're telling us that we already know the person travels by bus, we are basically able to narrow down the sample size. And we're able to say, instead of looking at all 400 people, because they told us that it was someone who had traveled by bus, we can basically say that we will narrow down our sample size to the number of people that travel by bus. So here, if you look at the column that says bus, that's a total of 175. So basically, what we're saying, in obviously not so many words because we're not actually saying this, but hypothetically, what we're saying is that instead of looking at all 400 people, we are now going to look at only the 172 people, 175 people, because we already know that it is a person who prefers a bus. So here we have taken it from 400, narrowed it down to 175, and that now basically says that we have fewer people that we're looking at in determining whether it is a female or not. So your numerator, then, we've taken care of the denominator. We know that we narrowed down the sample size because now they had said to you that it is known, they said, given that the person is traveling by bus. Now for the numerator, it's simply the probability of a person who is female and who travels by bus. So the numerator here is, and I'm going to write it here at the top, is the probability of selecting a is the probability of selecting a female, and this is a symbol we use for and. It's like an upside down U. You will see that in the slides as well. So female and bus. So now if you go to the table again, in the table, in line with female, in line with bus, and you just literally use a pen to bring it down to, or narrow it down to that. So that is 90 out of the total of 175. So as a percentage, that's 51.43%. So when we write that out in D here, you would say that in terms of the question, firstly, you would say, what is the probability of selecting a female given, and the straight line? It looks like a forward slash, but it's straight instead of diagonal or at an angle. So it says female, and that sign, that straight line, means the word given. So female given that they travel by bus, meaning that you already know in advance that they travel by bus, and you are now narrowing it down to how many of them are female who do travel by bus. So here you'll say the probability of selecting a female given that you, sorry, I just want to read the questions. So the word given was not included in the third one here for C. They didn't say to you that it was given that the person had traveled by taxi. They just wanted to know the probability that it was a male and the person uses a taxi. Here, they specifically use the word given, and that's how a conditional or a dependent probability will work, because you are saying that you already know that the person is traveling by bus, and now you just want to be able to determine the probability that they're female, given that they travel by bus. So you'll say the probability of female given that they travel by bus. And here, as I said, you narrowed down and you made the denominator, the part that's given, the number of people that only travel by bus, and that was 175. And your numerator is now both of them, female and that they travel by bus. So that was 90 over 175. And as a percentage to two decimals, that was 51.43%. Okay, then you have E, which says, what is the probability of randomly selecting a respondent who is male or who travels by a taxi? So now instead of using the word and, instead of using the word given, they've used the word or. Now, there's a specific formula for this, there's a specific rule for this. And the rule is called the non-mutually exclusive rule. Again, this is something that you'll have to read through in your slides to understand how this is carried out, why we call it a non-mutually exclusive rule. Basically, it's because it is two events that can happen at the same time, and we are trying to calculate the value of them. So in terms of non-mutually exclusive, the actual definition of it is that it's looking at two events that can occur simultaneously, but where we look at the calculation, it's looking at what's the chance of the one occurring or the other or both of them occurring. And that's literal to the word or in the question here. So as a general formula, and I'm going to write the general one first, and then I'm going to replace it for with the values for this question specifically. So the general formula will say the probability of A or B, this is a symbol that denotes the word or. It's basically, it looks like the letter U. So it's similar to the letter U, except it doesn't have that like line there. And this means, so like this, and it means or. And then the upside down, the opposite of that is and. Okay, so back to this question, the formula at the top, when you want to calculate the probability of A or B, it's the probability of A individually plus the probability of B individually minus the probability of A and B. So now we're going to, and you'll see with this one, it actually can be done as one formula. You don't need to separate them, or you can separate them if you feel more comfortable doing so. So what I'm going to do now is I'm going to replace A and B in the formula. What I'm going to replace it with is what this question specifically is asking you for. So this specific question says to you, what is the probability of selecting a male, a person who is male, or a person who travels by taxi? So here it's going to be male or taxi. So it'll be the probability of a male plus the probability that the person travels by taxi minus the probability of a male and a person who travels by taxi. So it's a male who travels by taxi. So now you're going to look at the first one, the probability of it being a male. So because this is one single variable, you're just looking at it being a male, you'll go to male in the table, and the total is 190 out of the 400. So 190 out of 400 people are male. Then you're going to add on the number of people who prefer to use a taxi. So you'll go to taxi. The total is 100 out of the 400 again. So it's 100 out of 400 who travel by taxi. And then you have minus the probability of it being a male and a person who travels by taxi. So now you're going to look at in line with male and in line with taxi, and that is 40 out of 400 people who are male and who travel by taxi. So I was saying to you just now that an alternative is, instead of doing them separately, because they all have the same denominator, you can actually make it one long formula. So you'll say 190 plus 100 minus 40, and that will be over the total of 400. Plus 100 minus 40, and that will be over the total of 400. So this then gives you an answer of 62.5 as a decimal when you work it out and multiply by 100. And so there's a 62.5% probability of randomly selecting a respondent who is male or who travels by a taxi. Okay, so that is E. And now we're looking at F. So F says, what is the probability of randomly selecting a respondent from the sample who does not use a car? So here, firstly, focus on the word not in the sentence. Now, this is important because, again, this word itself, like the word given in that earlier question, this word not, it signals to you that it is the complementary rule, meaning that you are looking at opposites. So the complementary rule, and this is a general formula. There's a general formula for this one as well. As a general formula for the complementary rule, I'm just going to erase at the top so I have some space here. Oh, sorry. So a complementary rule says the probability of A not occurring. So not occurring is where you write the letter or the alphabet or the event with the line on top of it. So the probability of A not occurring, literal to the word complement, is calculated as 1 minus the opposite of this. So it's 1 minus the probability that A will occur. So this is the probability that A is not occurring, and this is the probability that A will occur. So a basic example of this, and this is something that is so common that we don't actually even realize we're working with in daily life. So if we were to say to you, what is the probability of it? So let me just write it and then I'll explain. Okay, so I'm just going to write it at the top so we can see it with the rule. So if I were to say to you that the chance of it raining today is 20%, and then I were to ask you, what is the probability of it not raining? So you write the word rain with the line on top of it. It indicates not raining. So all you're saying is that the probability that it doesn't rain is 1 minus the probability of, and it's the opposite of that. So if this is saying not rain, this is saying that it does rain. So it's 1 minus the opposite. And this is then saying to you, to calculate the probability that it will not rain, you must say 1 minus the opposite, which is the probability that it will rain. And then if I were to, and remember I said if I told you that there is a 20% chance that it will rain, all you're going to say is say 1 minus 0.2 or 20%. So there's a 0.8, or as a percentage, an 80% chance that it will not rain. So it's pretty straightforward if you look at it from this perspective, because automatically then if there's a 20% chance that it rains, there's naturally then an 80% chance that it will not rain. So this is exactly what a complementary rule is about. It's where you say that the probability of one event occurring is 1 minus the opposite. So in this case, in F here, when we are calculating this value, we're going to say, and I'm just going to clear that, they said to you, what is the probability of selecting a respondent who does not use a car? So the probability of not using a car, you'll write the word car with the line on top of it. This is calculated as 1 minus the opposite, which is the probability that they do use a car. And now you're going to say 1 minus the probability that they do use a car. Here's car, and the total is 125 out of 400. So it's 1 minus 125 out of 400. So this then will give you an answer of 68.75% as a percentage. All right, so this is then how you will calculate your complementary rule. Please, can I ask that you pay special attention to this that I'm about to explain to you for the same complementary rule. If you are looking at this question and they had said to you, what's the probability that a person will be someone who does not use a car? If you say to yourself that since it's not a car, that means it will be the other two, which is a bus, which is 175, and a taxi, which is 100, and you say to yourselves, let's just add them, because that's the same thing as saying that it's not this one. It's not the 125 out of the 400 car, out of the 400 in total. This is not going to get you the full marks. Generally, a question like this is for about 4 marks. Sometimes, in the very rare occasion, maybe more than that. But most of the time, it's about a 4-mark question. But they are testing your knowledge of complementary rules. So you cannot just say that if you're looking at the possibility that it's a person who doesn't use a car, we can simply add up the other two, and that will tell us the probability of it not being a car, but instead it is the other ones, buses and taxis. That's not the same thing, because there you're not, by adding those two up, you're not using the complementary rule. So you have to use the complementary rule by saying that if they're asking you what's the probability that a person does not use a car, you need to write down the probability of it not being a car, and that's calculated as 1 minus the opposite, which is 1 minus the probability that they do use a car, and then it's 1 minus, and the opposite, which is 1 minus the probability that they do use a car, and then it's 1 minus, and you go to the number of people that use a car from the table, and that is 125 out of the 400 people. So it's 1 minus 125 out of 400, and that gave you the 68.75. Okay, so that is it for question 1. And I'm actually going to leave out question 2 because you're going to try this one out on your own. And I will make the solutions available for it, but you're going to try that one out on your own. So it's pretty much exactly the same thing as the top. So it's just that the table is different because this is based on mode of transport. This is based on which service provider people prefer. There are 500 people, remember, in total, and then they ask you a couple of questions, like very, very similar to the ones at the top. So just like the ones at the top, where they either are saying to you it's one thing that you're looking for, or two things. Sometimes they use the word and, sometimes they use the word or, sometimes they use the word not, sometimes they use the word given, that kind of thing. So it's very, very similar to the questions at the top, almost identical, except for the fact that obviously because the table is different and has different values, you'll naturally have different answers there. Okay, so you can try that one out on your own. Let us move on to the next page. Again, I do have another video that is going to have the, well, it'll have another explanation of a table like this with calculation similar to this. So you'll also be able to listen in on that one. So let's look at the next page. Are there any other questions so far? Okay, perfect. So let's move on to the next one. So here we are also going to work with certain of these questions. Let's start off with the one at the top. So this says to you that there are 14 runners in a 1,500-meter race. What is the probability of predicting the first 5 runners to finish the race in the correct order? Give your final answer as a fraction in its simplest form. So here, this is something that is called the permutation rule. So again, it's explained in the slides. It's towards the end of the learning unit. It's something called a counting rule. And so I'm going to just say here, it's accounting. Sorry, it sounds like I'm saying accounting, as in the subject accounting, but it's actually counting. So it is something called a counting rule. And this is, it has 3 categories within it generally. So you have the permutation rule, the combination rule, and then you have a rule for multiple events. So all of it is explained in the slides as well. And then again, there are other videos that I have that will show you examples of these, but it's actually a very straightforward calculation. And it is a permutation rule because they mention to you that the order, sorry about that. Okay, so they mentioned to you that the order is important. So I'm going to underline here. Ah, sorry about that. It sounds dreadful. So they said to you that the order is needing to be correct. Basically, that the order is important. So the moment they say to you that it needs to be in the correct order or that the order is important, this says to you that it is the permutation rule. So I'm just going to write that under here to indicate that it's the permutation rule. And in terms of the permutation rule, the formula for it, so there's 2 formulas, but I'm going to show you the easier one just because it is one where you can just use your calculators for it. And either way, you will get the same answer regardless of whichever rule you use. So there's one in the slides, and you'll be able to use that one. So because that's in the slides, I'm going to show you the other one, which is the one that you can use your calculators with. So it is N with a capital letter P to indicate permutation, and then R. So immediately here, and this is the easiest way to do this calculation, N in the formula is always the larger of the, actually let's start with P so that you can eliminate it basically. So the letter P, the capital letter P, there's no value for it. This is what you are entering on the calculator, and I'll tell you where to find it on your calculators in a second. So basically, P is not something that will have a value on your in your formula, in this formula you see on the screen. So you don't need to worry about P. So immediately I'm going to put the letter P in here, and then we're only going to substitute values for N and R. So N, and this is again the easiest way that you can identify, it's always the larger of the 2 values. So at the beginning, they told you that there's 14 runners. And then in the question, they said that they needed to predict the first 5 runners. So one value is 14, that's your total, which is n. N is always the sample size. So that is always the larger value. And then you're predicting the first 5. So R is equal to 5. And that is literally it. And you're going to put it onto your calculators in exactly the same way. So on your calculators, if you have it close by, please try it out. So you'll type in the number 14, then you'll press shift on the left-hand corner, and then it's above the multiplication sign on your calculator. So you'll press shift and the multiply button, and this will bring up the letter P, the capital letter P on your calculator. And then you'll type in 5 and you'll press equal to, and that will give you 240,240. Okay, so that's your answer, but it's not the final answer because they said you give your answer, your final answer, as a fraction in its simplest form. So they want you then to say that, and all you're going to do is literally make that 240 the denominator, and as a fraction it will be 1 out of 240,240. So that's literally all you have to do. Just convert it to a fraction. It will be 1 over 240, meaning that to predict one of the ways in which the first 5 runners will appear is a 1 out of 240,240 ways. So you'll see when you read through the slides for this learning unit that counting rules, literal to the word counting, is basically looking at the number of ways that someone can, or sorry, that something can occur. Like, for example, and I think this is also one of the examples in the slide, if they say to you, we have 6 swimmers and we want to predict how do we place them in the starting lineup for the race. Now, you're going to say that we can put exactly as they're standing, we can put them in position 1, 2, 3, 4, 5, 6. Then we can maybe arrange them backwards. So we can put the person who is standing 6, we can put them at number 1. Then the next one will be the person who was at 5 can come to number 2. The person who was at 4 can come to number 3. The person who was at 3 can come to number 4, and so on. So we can arrange them in that way. Then, so I'm just going to write it randomly here to show you, or let's just give them names so you can easily see that. Or let's just say A, B, C, D, E, and F. So we can leave them as that. That's one way we can arrange them. Then another way is maybe we can do them in reverse. So we can put F first, then E, D, C, B, A. That's another way. Then maybe we can, let's put them in order of A, D, I'm just doing random things here, okay? A, D, B, C, F, E. Then we can maybe start with E and go E, B, F, A, C, D, and so on. So if you look at it, although if you just think about it, it's only 6 people. I mean, how many ways can we really rearrange them? But the possibilities are so endless. There's so many different ways that we can't actually count every single way. And that's the same idea as what we did at the top here. They said to you that there are 14 people, and we want to know how can we predict the first 5 in the correct order. Now, basically what they're saying is that 5 people out of 14, how do we predict who comes out first, second, third, fourth, and fifth? So there's endless possibilities. And because it's so many to count, we use this counting rule to calculate it because it's too many for us to count. It's too many numbers. And we saw that from the answer here as well. The answer was 240,240 different ways that we can predict the first 5 people. which obviously would not have been possible if we had to sit and actually count and work out and determine how those five people would appear, or which five people would appear in terms of the first five. So this is why we use these counting rules, because it becomes too much to actually calculate. So instead of actually counting them, we use a rule that can help us on our calculators to, or even using a formula to calculate what the possible outcomes or the number of possible outcomes could be. Okay, so this is just to explain to you why we use these counting rules. Then you have for number 4 here, it says to you, oh, sorry, the calculator part. Okay, so you need to type in 14, P, and 5. So you'll type in the number 14 first, then you'll type in, or you'll press Shift and the multiplication sign on your calculator. And then this will give you the letter P. So you have 14 and you have P, and then you'll type in 5, or you'll press the number 5 and then equal to, and it will give you the 240, 240. Okay, so that was number 3. Let's look at number 4. So number 4 is pretty much the same thing. The only difference is that now it's, instead of being in the correct order, the order doesn't matter. So it says Gloria has 14 employees. She has to choose 7 of them for a project team. In how many different ways can she select these 7 people to make up the team from the 14 that she has? They did not mention anything about the order being important. So immediately it says to you that it's not a permutation. If it's not important, if order is not important, it's called the combination rule. So a combination rule is very similar. Instead of P, it's the letter C. So it's NCR. And this then, again, you do not have to enter a value for C. It's just something on the calculator. So we're going to leave C as is. So basically that means we only need values for N and R. Again, N is always the larger of the two values because this is your sample size. And they said to you here again that you have 14 employees to select from. So it's 14 as N. And R is that you need to choose 7 of them. So R will be 7. So again, on your calculators, you'll type in 14, 1, and 4. R will be 7. So again, on your calculators, you'll type in 14, 1, and 4. Then you'll press Shift. And this time, it's the divide sign. Above the divide sign, you'll see it says NCR. Above the multiplication sign, you'll see that it says NPR. So this is what is basically representing the permutation and the combination rule on your calculators. So shift and the divide sign, and then the number 7, and you'll press equal to, and this will give you 3,432. So there's 3,432 ways that she can rearrange 7 people out of the 14 people to make up her team. Again, it's something that is not realistic to actually count for yourself. So this is why we use a calculator, because we're basically saying that there is so many different ways for her to select 7 people from the 14 people. It's not something that is possible. Well, it is possible, but it's just easy to make mistakes, easy to leave out figures, easy to go wrong when you're working with such large numbers. And this is why we use the combination and the permutation rule. Okay, so these are the calculations for your number 3 and 4, your combination and your permutation rule. Then for number 5, and I'm going to go through that one pretty quickly, it's also very similar. So number 5, I'm only going to do A actually, because B and C here are the combination rule and this is the permutation rule. So you can work that one out on your own. Let me do the first one. So it says in deciding how to spend her time on holiday, Jody can select from a list of 4 different cities to tour, 5 different movies, and 5 different restaurants. So 4 cities, 5 different movies, and 5 different restaurants. Then it says how many different combinations are available to her if she wishes to do one of each. All you have to do with this is called a multiple event or a combined event. And all you have to do is simply multiply the options by each other. Meaning there's 4 different cities, multiply that by the number of different movies, which is 5, and multiply that by the number of restaurants, which is 5, and that will give you a total of 100. So there's 100 different ways that she can combine one city to one movie to one restaurant. So again, it doesn't actually seem like that. When you think about it, you think to yourself, how many different possibilities are there really? But when you work it out, and when you actually sit down and combine them and equate them and basically match one to the next, it actually ends up being a lot more than would have been possible to count. So this is why we use the counting rule, because it is too many, it's too monotonous, and it's easy to go wrong. Okay, so that's number 5. Let's look at number 6. So number 6 and number 8 are pretty much the same thing. So I'm just going to work with number 6. You can try out number 8. And the same with number 9 and 10. So I'm going to do the more difficult one. I'm going to do number 10 because your assignment will also have something similar to this. And you can try out number 9 on your own. At the end of the session just now, I will circle which ones you need to try out. And then in about a week's time or so, I'll upload the solution so you can check your answers to those. Okay, so let us work with number 6, number 7, and number 10. Okay, so number 6 is also something that you will need to read through in the slides, but I'm going to show you how to do this. This is honestly more of a mathematical question than a statistical one, but we're obviously going to go through it anyway because I'll show you how to take over to the other side, how to substitute, that kind of thing. Okay, so it says to you events X and Y are such that. So you have 2 events, X and Y. It's such that the probability of X is 0.45 and the probability of X or Y, remember that symbol that looks like a U, like the letter U, it symbolizes or. So X or Y is 0.85. So they said, given that X and Y are independent and they are non-mutually exclusive, determine the probability of Y. Now, from this, you basically know that there are 2 events, X and Y. You know the probability of one of them. You know the probability of X, and you know the probability of X or Y occurring, but what they didn't give you was a probability of Y, and that's what you're calculating. So let's calculate that. So what you're going to do is they said to you that the events are independent and they're also non-mutually exclusive. So there's 2 things here, independent and non-mutually exclusive. The first thing you're going to do is write down the formula for the non-mutually exclusive event. And this is something I read to you on the previous page. Also, it was, I'll tell you which one. It was E here on this page. So this is where a non-mutually exclusive event, the formula for it is, so we're using X and Y here, not A and B. So we're using the letters X and Y. So you're going to say the rule for a non-mutually exclusive event is that the probability of X or Y is equal to the probability of each one, so the probability of x plus the probability of y, and it's minus the probability of both x and y. So you started off by writing out that non-mutually exclusive event. Then you're going to write out the independent event, and you're not going to write it at the bottom here yet. I'm writing it at the top, and I'll explain to you why I'm writing it at the top just now. So, sorry, I just want to take out all this. So the independent rule, and I'll use the letters X and Y here also. The independent rule, and you'll see this in your slides again, it says the probability of X and Y, so X and Y, is calculated as the probability of X times the probability of Y. Now, once you have both those formulas written down, you go back to the first one and you identify what looks the same from what you have written down in this formula to the independent rule formula. And if you look at it, this last part here, where it says the probability of x and y, it's the same thing as the first part of the independent rule formula. So basically what you're now going to do is substitute, meaning in place of x and y, the probability of x and y in this formula, we're going to replace it with what this actually stands for, what it actually represents, which is the probability of x times the probability of y. So I'm going to rewrite that entire equation, only changing the last part that was highlighted, because that's the only thing we're replacing in the formula. So it's a probability of x or y is equal to the probability of x plus the probability of y minus the probability of x times the probability of y. So now we've basically incorporated one formula into the other. And we took care of both the fact that they mentioned it is independent and they are non-mutually exclusive. Now you're going to substitute for what you do have, what values were given, to work towards what you needed to calculate. So they gave you the probability of x or y. That's what's on the left-hand side here. It was the 0.85. So you'll say 0.85 is equal to. They also gave you the probability of x. It's the 0.45 plus. We don't know the probability of y. That's what we're trying to calculate. And then it's minus, and you have within brackets here the probability of x, calculate, and then it's minus, and you have within brackets here the probability of x, which again is the 0.45. So keep the brackets, 0.45 times the probability of y. So we don't know the probability of y, and we'll just leave that as is. Now, if you would have noticed in that bracket at the end here, I didn't put in the multiplication sign again. And the reason I didn't put it in again is because with your normal math rules, you don't have to put in a multiplication sign. If you don't have a sign between two variables, it is a given that it is multiplication. So here, we don't actually need to put in the multiplication sign, because saying 0.45 py or probability of y actually means it's 0.45 times the probability of y. But we don't need to write it down and show the multiplication sign, because it's a given that it is multiplication. Meaning, if I were to write 2y, it actually means 2 times y. Or if you were writing 3x, it actually means 3 times x. So as long as you have two variables that are written as one, it's a given that it's multiplication. Okay, so now we can move on to the next step. Before we continue with it, I'm going to open up the bracket. So it's just writing everything as is, exactly the same. And only at the end here, we're just going to open the bracket. So it'll say minus 0.45 py. Now all you have to do is normal math rules, take all of the values or the numbers onto one side and leave all of the variables on the other side. So the only one that has a number without a variable on the right is the 0.45. So you're going to take that across. So it will say 0.85 on the left. And now you're bringing the 0.45 across. So it is plus here. It will become minus on the other side. Remember, whenever you're working with values and fractions and equations and so on, and you're taking a value from one side to the other, from the right-hand side to the left-hand side, or the left-hand side to the right-hand side, you always change the sign. If it has no sign, it is a positive value. Like here, 0.45 means it's a positive 0.45. So when you take it over to the other side, it'll become a negative. So it will become minus 0.45. And now on the right-hand side, you're left with, so you got rid of this, and you're left with only these two. So it says py minus 0.45 py. Okay, so now you can work out the actual values on either side. So on the left-hand side, 0.85 minus 0.45 is 0.4. And on the right-hand side, first write down the variable because that's not changing. And now for the numbers. Remember, there's always an invisible 1 in front of a variable that has no number. Meaning, if I write x, it actually means 1x. Or if I just write down the letter y, it actually means 1y. If there's no number in front of it, it's a given that it's 1. So this would mean it's 1 minus 0.45. So this is 1 minus 0.45 is 0.55. And that, so we're here now at this point. I'm just going to write it again here so you can see it neatly and clearly. So we're currently at the point that says 0.4 here. I'm just rewriting this. 0.4 is equal to 0.55 py. Now we want to calculate this value only. We want to know what is the probability of y. That's what they actually asked us to calculate. Here's the question here. Determine the probability of y. Sorry, you can't really see it amongst the writing there. I can maybe erase here so you can see that nicely. Okay, so they said to you, determine the probability of y. So in order to determine the probability of y now, all you need to do is get rid of the 0.55. So to get rid of it, again, there's no sign between the 0.55 and the py. Automatically, that means that it's multiplication if there's no sign. So this means in order to get rid of the 0.55, you need to take it to the other side. And since it was multiplication on the right-hand side, when you take it over to the left-hand side, it needs to become the opposite. And the opposite of multiplication is division. So it'll be 0.4 divided by the 0.55, and that will tell you what the probability of y is. So now you're going to divide that, and on your calculators, that will give you, so since the others were 2 decimal places, we can leave this as 2 decimal places as well. So that will give you 0.73 as your probability of y. Okay, so it is a long process, but you can pretty much guarantee that a question like this will come out in your assignment as well as your exam. So please make sure that you practice this. I have again another video that does explain again exactly like I explained here, the whole process from the start where you're substituting and then taking over to the other side and so on, exactly like I explained it here. I do have another video of this. I will make that available as well. And again, you can try out number 8 here on your own. And when you try that out, as I said, I will upload the solutions to that for you, and then you can check your answers. Okay, so that is number 6. Let's look at number 7. I'm so sorry. I know I'm going over time, but I'm almost done. It's just number 7 and 10 that's left. Okay, so let's go through number 7. I'm just going to erase this. So number 7 says to you that a female student flips a coin and rolls a dice. So here they say to you, assume statistical independence. What is the probability that she will obtain a tail from flipping the coin and obtain an odd number from rolling the dice? So firstly, we need to identify that they said to you that these events are independent. And immediately again from that, if you write down the independent rule, and I actually already have it written here at the top, it says to you, there's a chart, this at the top here, that if it's independent events, or if two events are independent, you simply take the probability of the one and multiply it by the probability of the other. So here we know that we're multiplying, but what values are we multiplying? So it says to you, the person, the female, had flipped a coin and she rolled a dice. They want to know the probability that she will obtain, let me clear here, she will obtain a tail when she flips the coin. And we need to first then identify what's the probability that she will land on a tail. So here, when you toss a coin, there are only two sides. So there's a 50% chance that you will land on tails. There's a 50% chance that you will land on heads. So the probability that she will land on tails is 1 out of 2, meaning 50% basically, since there's only 2 on tails is 1 out of 2, meaning 50% basically, since there's only 2 possibilities. And then the probability that she lands on an odd number when she rolls the dice is what we need to multiply this by. So when you roll a dice, there are 6 possibilities. You can land on the numbers 1, 2, 3, 4, 5, and 6. Now they want to know, so our denominator is 6 because we know there are 6 possibilities. We want to know what is the possibility that she will end up on an odd number. So the odd numbers are 1, 3, and 5. That's 3 out of 6, which is also half, 1 over 2. So you're simply multiplying those. It's 1 over 2 times 1 over 2. Or you can even say 50% times 50, or 0.5 times 0.5. That's exactly the same thing. There's a 50% chance times 0.5 again, and that will give you 0.25, which is 25%. It's the same thing that you'll get here as well if you left them as fractions. So there's a 25% chance that she will land on tails if she flips the coin, and a 25% chance also if she of her landing on an odd number if she rolls the dice. Okay, so 25% chance, then if you have to interpret that, there's a 25% probability that she will obtain a tail when she flips the coin and an odd number if she rolls the dice. Okay, that's number 7. And then, as we said, you are going to try out we went through those. We went through 5A. We went through number 3 and 4. And you can try out number 8 and 9. I'm going to do number 10. So let's go through this one quickly. It says a bag contains 8 red and 6 blue marbles. You are asked, actually, before I move on with that sentence, let's look at, they said to you, 8 red and 6 blue marbles. So firstly, from that alone, we know that we have a total of 14 marbles because you have 8 that are red, 6 that are blue. So in total, that is 14. So immediately you're going to then say, and I'm just going to clear up the screen here a bit, and then I'll have some more space to write. So I'm just going to write this at the top now again. So of the marbles, 8 of them are red, 6 of them are blue. Collectively, we said we have 14. Okay, so then they say to you, you are asked to select 2 marbles from the bag. But when you select the first marble, you don't place that marble back into the bag. So we need to consider this because this is going to affect your calculations. So then they said to you in A, construct a probability tree for the various possible outcomes that may occur. Now, one important rule that I can mention and that you will need to make note of, it's also in your slides, is that probability trees, they are always based on the independent rule. And remember, we said just now that the independent rule basically means that we multiply. That's what we did just now in question 7. Okay, so now let's draw up the tree, and we also need to show the various possible outcomes. So when you draw up a probability tree, and in particular for this question, they said to you there were 2 marbles. So we need to show them accordingly as well, as in when the first marble is selected and then when the second one is selected. Now, when you're going into the process, you need to think of it from the perspective of this is what is going to happen. So when you are going to choose the first marble, you're going to do the first part of the tree. And you said at the top, we had indicated that 8 out of the 14 marbles are red, and then 6 out of the total of the 14 are blue. So that's literally what you're going to show for the first part of it. Now I'm going to switch to the whiteboard here so that you can see it nicely because I don't have much space to draw. Okay, so here we go. So here you're going to say again, and I'll just write down what the important parts were. We said that 8 of them were red and 6 of them were blue. And collectively there was 14. So we're going to say when you are selecting the first time, you can either select red, and if you're selecting red, 8 out of the 14 are red. So there is a possibility that you will select any one of the 8 from the 14 and it will be red. And then you can also select blue, and 6 of the 14 available are blue. So that's the first time around. Now you're going to look at what happens the second time around. Remember, they said to you in that question that after you select the first marble, you do not place it back into the bag. Now, immediately that says from the 14 that we had available, there's now 1 less available. So you only have 13 to choose from. So The first thing, and I'm going to show you, I'm going to draw it up first and then I'll explain it to you. The first thing you're going to do is you're going to indicate that instead of 14 being the denominator, like we showed the first time, we now only have 13 to choose from. Now, why did we draw up 4 branches? 2 from the first one, 2 from the second one. The reason we do that is because, and again, I wrote down on the previous page, that probability trees are following the independent rule. Meaning, and the word literal to the word independent, what happens the first time around has no impact on what happens the second time around. The events are completely independent of each other. They do not have an impact on each other, meaning what you selected the first time does not impact what you select the second time. So if you selected red the first time, the second time you can also select red again, or you can select blue. And it's the same at the bottom. If you selected blue the first time, you can still select blue again, or you can select red. So they're completely separate, isolated, independent events where what happens the first time does not impact what happens the second time. So this is why from each of the options that you initially had, you now are drawing 2 further branches from that to indicate that what happened the first time does not affect what happens the second time, and you can still choose either red or blue the second time despite what you had chosen the first time. So this is why you have red and blue, and again red and blue at the bottom for the second part of the tree. And your denominator is now 13 because you had chosen 1, you did not replace the marble, that left you with 1 less. Now you're going to focus on the first part of the table, meaning this. Ignore this part at the bottom. So I'm just going to say here, ignore this part here. Just for now, while we work on the top, ignore this whole part at the bottom. So let's this part here. Just for now, while we work on the top, ignore this whole part at the bottom. So let's focus on the one at the top and let's calculate or determine what the values are for the numerator. So for the numerator, you need to look at it in terms of what happened the first time. Now, if you selected red the first time, so here when you had chosen the first marble, if you chose red the first time, that means that when you select the second time, you have 1 less red available. So basically, you're saying from having 8 red, if you, and again, this is why you're treating each of them individually. If you had 8 red at the very start and you selected the first marble, if it was red, that means that there's 1 less available of the red marbles. So now when you go to select the second time, there's only 7 of the 13 that are red. Then again, if you selected red the first time, that means that for blue, so this is now this part, we're doing blue. If you selected red the first time, then you didn't touch the blue at all. So the blue will be whatever it did start off at. So that means whatever was blue at the beginning, it will still all be there because you selected red the first time, so you didn't touch the blue marbles. So that's the first part of the table, or the first part of the, or the top half, sorry, rather, of the tree. So let me take out that, and now let's do the bottom. So I'm going to take out the words erase here, and the word ignore here, and we're now going to look at only the bottom. So we're doing only this part. So now it's the opposite. Now if we started off with 6 blue and we had chosen one blue the first time, that means there's only 5 blue that are available. So for blue, there's only 5 blue that we can choose from. But if we chose blue the first time, that's here, then the red was untouched. So the red will be whatever it started with. And we started, and I'm highlighting it in the corner here, we started off with 8 red. Here it is here. So the 8 red was completely untouched because you selected blue the first time. So all the red that was there at the beginning is all still there because you had selected blue the first time, so you did not touch the red at all. And that is the probability tree drawn up and completed. And now we're going to work with the outcomes of it. So this was only drawing up the tree. This was not the actual the entire question. This was only the first part of A there in those questions. So now to calculate the possible outcomes, you don't have to write this heading like I am here. I'm just showing you how to determine the outcomes. Again, it's based on the independent rule. And I said to you, that means we multiply. So when we say we're multiplying, what that means is we're going to multiply the outcome of the first event by the outcome of the second event. So basically, and I'm going to say here, multiply. So, and I'll show it to you with a highlighter first, and then we'll calculate it. So you're going to say the first option is that we select red the first time, and then we select red the second time again. So I'm going to say here, this was the first marble, these were the second marble outcomes. So we said red, the probability of red the first time, and red the second time again. And you simply take their fractions and multiply them. So 8 over 14 times 7 over 13. And that will give you 4 over 13. Then the next one, and I'm going to do this in a different color, is red the first time and blue the second time. So that was red, the probability of red first, and then blue. So again, multiply their fractions, 8 over 14 times 6 over 13, and that is 24 over 91. Then the next one is at the bottom, blue the first time and then red the second time. So it's the probability of blue and then red. So that's 6 over 14 times 8 over 13. And that's 24 over 91 as well. And then the last one is blue the first time and then blue again the second time. And this is 6 over 14 times 5 over 13. And that is 15 over 91. Okay, so that is the entire probability, 15 over 91. Okay, so that is the entire probability tree now, and you've drawn up the tree together with the possible outcomes. Okay, so now let's look at, and there was just one last question associated with this diagram. So I'll come back to the diagram in a second. Actually, let me just write down the question here. Let me just check what that question was. So it said to you, what is the probability that both marbles selected will be of a different color? So I'm just going to write down that question here. What is the probability that both marbles selected will be the same color. Sorry, will be of a different color. Selected will be okay, so this was a question. What is the probability that both marbles selected will be a different color? So all you're going to do here, and your answer will always come from the outcomes. So all you're going to do is in the outcomes that you've drawn up. Sorry, I just want to highlight. Okay, so in the outcomes that you've drawn up, you're looking for, they said, both marbles being a different color. So you want to look for under the outcomes, and in particular, look at this. So look at everything in this first, I want to say column, but then I didn't actually make it a column, but basically everything in this column here. Look for the ones where there are different colors. So it cannot be the first one because that's red and red. It also cannot be the last one because that's blue and blue, meaning they're the same color. We are looking for different colors each time. It can definitely be this one because that's red first and then blue, so that's two different colors. And it definitely can be this one as well because it's blue first and then red, so different colors each time. So basically what happens is you simply add those probabilities up. So you take the 24 over 91 plus the 24 over 91, and that will be your answer. So you will then say that to write down your answer, you'll say, and I'm just going to change the color of the pen here so you can see what the answer is. You'll say it's the probability of red and blue plus the probability of blue and then red. So that is the probability of red and then blue is 24 over 91 plus the probability of blue and then red is also 24 over 91. Leave your answer as a percentage to two decimals. So it'll be 52.75%. Okay, so that is it. I am so terribly sorry that I have taken up so much of your time, but I'm hoping that this will make it easier for you with your assignments. I'm sure it will be. Um, do you mean how you get it as a fraction, or do you mean that your answer wasn't correct? So on your calculators, if you're getting your answer as a decimal instead of a fraction, there is a button. I think it's above. Let me just check if I can tell you where it is. I think it's above the. Is it A N S? Sorry, give me 1 second. I don't have my calculator with me, but I can just Google and I will find the image of a calculator and tell you what button it's above. So it's basically a button that says SD. It's above the delete button on your calculator. So on your calculators, your Casio calculators, you'll have two orange buttons on the right hand side. Above the one that says delete, it says S and it has like an equal to or squiggly equal to sign or basically a change sign. So it looks like this S and then it has arrows like that and it says D. So this converts your answer from a decimal into a fraction. So that's how you'll get the 24.91. In question 7, where did we get the denominator of 6? Let me go back to question 7. Okay, so this was for the rolling the dice and the tossing of the coin. Okay, so remember they said that the person is flipping a coin and rolling a dice. So when you flip a coin, there are two options that you can land on, or two outcomes. It's either heads or tails. And then with rolling a dice, there are 6 possible outcomes. So this is, remember, you can land on the number 1, 2, 3, 4, 5, and 6. So that's where the denominator of 6 comes from. So they asked you what's the possibility of landing on tails. So it's 1 out of the 2 options. So that's 1 over 2. And then we said you multiply it by the probability of obtaining an odd number. So the odd numbers, there's 1, the number 1 is an odd number, the number 3, and the number 5. So that's 3 out of the 6 possible outcomes. So that would be 3 over 6. Okay, perfect. Is there anyone else that has a question? That's great. Thank you so much, Brad. Okay, so that's it from me. Again, terribly sorry that I have taken up so much of your time, but I promise it will prove to be very, very useful for your assignment 2. Again, the questions that I did not go through is, and I said to you at the end, I will circle them. So I didn't go through question 2 here. And then on the next page, we did not go through 5B, C, 8, and 9. Okay, so please have a go at those. Try them out. Get a feel for it. I will upload those additional videos for you. And in a couple of days' time, I will upload the solutions of this worksheet for you as well. So you can have a look at the ones that you will try out on your own to check whether your answers are correct. Again, if there's anything that you're having trouble with, please pop me an email or ask me in the next session. I'm happy to assist. Have a go at your assignment as well. Look at the questions there from this learning unit that are, you'll see there's quite a few that are quite similar to the ones that we went through today. So with everything that we've covered up until today, you will definitely be able to complete your assignment 2. But again, obviously, we'll be having an NSS session. I will let you know when that will take place. And I will also let you know once I've uploaded this video onto YouTube, and I will upload this worksheet for you onto VC Learn. Thank you, everyone. Enjoy the rest of your evening and your week, and I will chat to you again soon. Cheers, everyone.